Okay, hello viewers. Welcome to my Tutor Kitty's live session. So today we are looking at synthetic division. Synthetic division. So synthetic division. Okay. So in our last class we looked at long division. Now we look at synthetic division. We see which one is nicer than the other. Okay. So long division involved the variables. It was dividing highest powered variable by this variable from the divisor. Now, what about synthetic division? So we go straight into examples. So use synthetic division. Okay, example 1. You are dividing f of x is equal to x power 3 minus 7x squared minus 4x plus 28. You are dividing it by x minus 3. Now, the beauty about synthetic division is that you go straight to the divisor. You go straight to the divisor, x minus 3, and you get it to 0. At next, you get x is equal to 3. You see this number? This is the number that we need. We'll write it here, and then draw this line, then block it. Then go to the divisor now, and get only the coefficients of the variables in descending order. So you start with the highest. X power 3, the coefficient is 1. X power 2, the coefficient is negative 7. X, it's negative 4. The constant is 28. So if you don't find the variable with that power you're looking for, you want x power 2, you find it's not there. You put a 0 as a coefficient. That's why it's not there. Anything multiplied by 0 is 0. And if you have 0, in most cases, you don't write it. I mean, especially in functions. If 0 is the coefficient, you won't write it. Okay. And then, to the first number, you add a 0. The answer you get, you put down. Now, this answer you get, you multiply by the number that is outside. That 3. That 3 is standing alone there. So you multiply by that 1. So you have 3 times that 1, you get 3. That 3 you get, you add it here. You see that? So you have negative 7 plus 3, which is what? Negative 4. And then get back to the 3. 3 times negative 4 now, we get negative 12. Add. So you continue adding. So now we have negative 12 plus negative 4. We get negative 16. Continue multiplying. So you have 3 times negative 16. Or what we get? I want to be sure. What is a 3 times 16? Oh, it's negative 48. So we get negative 48. Then we add. So we continue the addition. We add. So 28 plus negative 48. We get negative 20. The last number is also a special number. The last number is called what? The remainder. Now remember, I always do that notation. I want everything to be a function because even a constant number is a constant function. What is a quotient? The quotient, be careful now here, the quotient will have variables. Okay? Here we have the coefficients of the quotient. We have the coefficients of the quotient. The variable is x. Our dividend had x power 3. Our divisor had x power 1. So you subtract that power 3 minus the power 1. We get power 2. So this will be the power of the variable this will be the highest power in our quotient variable. Now, our variable is x. So the coefficient is 1. So we're going to have 1 multiplied by x to the power 2 minus 4 multiplied by x to the power 1 minus 16, the constant. This can be written now as x squared minus 4x minus 16. Now the question demanded that we must, it didn't demand, anyway, we should always be leaving our answer connected. Here, you write as divisor, quotient, plus the remainder. So you do x minus 3 multiplied by the quotient, like that, plus the remainder. The remainder is negative 20. So that's the thing. You see that? That's our solution. That's our solution. That's our solution. Synthetic division. Very nice. And if you have any space to use synthetic in an exam, please use it. Why is it best? Time saving, accuracy. Simple. You save your time, you enjoy it, and there's no room for making errors here. I mean, where do you make an error? Nowhere. You just go straight to the answer and you have it. Okay. Now, I want to do another example of this. What I will do now is I'll go straight to a question that will need synthetic, more of application to factorization, so that we see how nice things become now. Okay, so I'll put this is an exam question. This is an exam question. So you don't just answer that one like this. Example 2. So I'll put the whole question. So let f of x be equal to, and let f of x be equal to 4x power 3 minus 7x minus 3. Okay. A, find the remainder. Find the remainder when f of x is divided by x minus 2. B, show that 2x plus 1 is a factor of f of x. C, hence or otherwise, solve the equation f of x is equal to 0. Okay, we go straight to the solution. So we are here for the solution. So we have f of x is equal to 4x3 minus 7x minus 3. Find the remainder when f of x is divided by x minus 2. Find the remainder when f of x is divided by x minus 2. We need the remainder. Now you choose, do I go for long division or I go for synthetic? I mean, why go for long division? Huh? Why go for long division? Let's go for synthetic. A. So using synthetic, we get x minus 2 and equate it to 0. We are looking for the value of x now. Oh, it's equal to 2. Wonderful. So now we'll have that 2 here. Block. We got the function and get the coefficients of the variables in descending order. So for x power 3, we put a 4. Is there x squared? There is no x squared. So we put a 0. 0x squared minus 7x minus 3. What next? We add a 0. We get a 4. 2 times 4, 8. We add, we get 8. 2 times 8, 16. We add, we get 9. 2 times 9, 18. We add 18 minus 3, we get 15. And don't we have the answer? So for part A, we have the answer. Okay, therefore, the remainder is equal to 15, the last number. And this question just said, find the remainder when f of x divided by x minus 2. So we're done. We are done. You get your marks. Okay, let's go to B. What does B require? B is saying, show that 2x plus 1 is a factor of f of x. Now, what is a factor? What is a factor? So a factor is a divisor that when you divide into the f of x, the remainder will be 0. So what determines whether that divisor is a factor is the answer you get here. If here we get 0, then the x minus 2 was going to be a divisor. I mean, it was going to be a factor. But we didn't get 0, we got 15. So it remains a divisor just. So now, we'll use synthetic to check if this guy is a divisor. So we're getting 2x plus 1 equal to 0. So for x, so x is going to be negative 1 over 2. We don't care whether a fraction of this kind, we still use it. Synthetic works. And that's the beauty about it. So we get the negative half. Get the function 4. We get 4, we get 0, negative 7, negative 3. And then, as usual, add the 0, we get a 4. We multiply. 4 times negative half, we get negative 2. Add. So we have negative 2 here. Negative half times negative 2, we get negative 1. Add, we get negative 8. Negative half times negative... What's happening? We see negative half times... I'm a bit confused. I'm not seeing it working out, but we continue. Negative half times negative 8. It has to be positive 4. When we add what we get, we're getting a positive 1. Show that 2x plus 1 is a factor of f of x. Is it a factor? Is it a factor? In this case, is it a factor? So we wanted to have a 0 here, but it's not 0. So if it's not 0, it won't be a factor. Now, we confirm. We confirm. So mostly if it says show, it has to work out. But we always leave room for errors. So we go back and check. First, I need to confirm. Was the question right? Was the question asking us to show? It was 4x. It was 4x power 3 minus 7x minus 3, correct? The divisor showed that 2x plus 1 is a factor. 2x plus 1 is a factor. And when we do that, we get negative half, correct? When we put the 4, then 0, then negative 7, then negative 3, then we do our division. So there we have a 4. So I'm just verifying here for the sake of confirmation. And then we have that. That will give us negative 2 for sure. We put negative 2 there. When we add a 0, we get that. Oh, okay. So when you add the 0, we get negative 2, correct? We multiply negative half times negative 2. Oh, okay. Negative half times negative 2. It has to be positive 1. Oh, wonderful. So this guy is positive 1. Meaning negative 7 plus 1 won't be negative 8, but negative 6. So now we spotted the error. So when they say show, it has to work out, guys. So we have negative 6, correct? And then from there, things work out, yes? Okay, so negative half times negative 6, we get positive 3. Oh yeah, negative 3 plus positive 3, 0. So when concluding, we say, since the remainder function is equal to 0, 2x plus 1 is a factor of what? Of f of x. So now see what I did. When I saw that I was not getting a 0, and the question says show that. If the question says show that, they are very sure. It has to work out. So if when I do that, I don't manage to show, I must recheck my work. Obviously, I'm the one who is wrong. So you check. Don't be too sure that you are right. Check your work. You must be wrong somewhere. Because if they say show, they've already checked it works, guys. You just have to show. Okay. So now, we got the next part. The next part says, hence or otherwise, solve the equation f of x is equal to 0. Now, when they say hence or otherwise, the hence part means from the answer you got in part B, solve the equation. The otherwise says, if you are not comfortable proceeding from the answer you got in B, use any method that you know to solve f of x equal to 0. That's what it means. So now, let's go for the hence. It's an option here also. So let's go for the hence. We continue from the answer we've gotten here. Okay. So we already have the we have the quotient here. So I'll do part C just here. So we have the quotient already. If we activate this guy, f of x is equal to 0. It's going to be, since the remainder is 0, so that part we add the remainder, we are going to add a 0, so it's okay. We're not going to add anything. So just have that product there. So the product we have is, we have x minus half, like that. Or first you see what happens, because if you're not careful here, it will not come out. So we write 2x plus 1 is what we have as our divisor, and then we'll have a 4x squared minus 2x minus 6. Okay, this should give us a 0, but now you must be very careful. When the divisor has a coefficient that is not 1, you must be careful with what happens here. Because if you try to expand this, it's not giving us the initial function up there. The initial function up there is 4x power 3. If you multiply this, you're going to get 2x times 4x. That's going to be 8x power 3. So it does not give that. So you don't write it like that, guys. Okay? You don't write it like that. Okay, so what do you do? So if there was a half there, if there was a coefficient there, in this case it's 2, There's a way we write it. So we're going to write it as, so I'll remove that part after I've written it in the way it's supposed to be written. So you're going to pull out that 2 and divide. Okay, so you want to write it as this guy, okay, and then x minus, so I want to write it in the form of x minus half, in the form of x minus half initially. That should be fine. Yeah. Or the simplest. Let me just go for the simplest. The simplest is, if it is like that, then because you know that your coefficient had that 2x plus 1 was used as x minus half when you're dividing. We use the negative half. So you put that half outside. So you just do that. You do that. And then you have 2x plus 1. And then the 4x squared minus 2x minus 6 equal to 0. So you put that half outside just to avoid going into 8. So whatever number that could be there, whether it was 3, it was what, you do the same. So you put it there. Okay? Please, guys, don't forget, if you don't put that, you get a wrong thing. If you don't put that, you get a wrong thing. Yeah, if you don't put that, you get a wrong thing. So now, if I put that, I know that it's going to take away. I'm not quick to do that to take their side, no. I want that to reduce things in here for my question to always work out. Be careful on that one. So what I'll do is I'll keep the 2x plus 1. And since I'm seeing a 4, 2, 6 there, I'll reduce that one. So it will be 2x squared minus x minus 3 equal to 0. So I've used that half to reduce the quadratic because I want to factorize that quadratic there. So to factorize the quadratic, I should have 2x squared. So the product is -6 and the sum is -1. So what we use? -3 and 2. So we have plus 2x minus 3x minus 3. And then factor out the 2x, so it remains with x plus 1, the minus 3, x plus 1. So here we should have 2x plus 1, and then x plus 1, and then 2x minus 3 equal to 0. Okay, and then you equate this piece each to 0. So for the first one, already know x is -half. For the second one, x is -1. For the third one, x is 3 over 2. These are the solutions. These ones. You see? So we get x is equal to -half, x is equal to -1, x is equal to 3 over 2. So where I want you to be more careful is when you are given the coefficient of the divisor, not 1. So you have to be careful when you arrange your polynomial for solving as an equation. Because if you don't take care of that 2, then your answer, when you try to multiply, it won't get back to the question. It will be 2 times 4 is 8. So it would go to 8. So every other part will be increasing by 2. Even the 7 was going to be 14. The 3 was going to be 6. So you reduce them and then now you do that calculation properly. You find that everything comes out correct. So this is synthetic division. Okay? So even long division can be used where they want a remainder here. If, because there are times you cannot use synthetic. If, for example, you are given the divisor to be x squared plus 1 or to be x squared plus 2, you won't manage to solve for the x that you should use in the synthetic division as a number to put outside, because that x squared plus 2 can be solved. You can't equate to 0 and find x, you cannot. So that means that you have to use long division. So that's the reason why you must know all the two methods. You must know long division. You must also know synthetic division. And then you check when they say find the remainder. That's an open question. They have not said use synthetic. They have not said use a long division. They have just given the question. You choose what to use. So depending on the question, you'll be quick. If the question can be solved, if the divisor can be equated to 0 and quickly get the value of x, then you go on and use synthetic. If you can't solve, you can't equate the divisor to 0 and get a solution, then please don't use synthetic. Instead, use long division. You see that? So, as usual, these lessons continue. There are a lot. They keep coming. There are live sessions and there are recorded sessions, depending on what you want. Please, if you are interested, you are doing 1120, you are doing 1100, you are doing 1110, you are doing any mathematics, engineering mathematics, anywhere, okay? You are doing introductory mathematics, anywhere, you are doing A levels, anywhere, and you really want to continue seeing these, please first do subscribe. If you haven't subscribed, click on the subscription button, you subscribe, and then if you want to have one-on-one or to join live sessions, please you contact 0771 34994. Oh, how many nines? 3 nines. So 994. So you WhatsApp this number. If you're not in Zambia, you add a 26 and then 0771 34994. So this on WhatsApp, please. You WhatsApp. Okay. So you WhatsApp. There, it will be easy to communicate. We can chat. So these lessons are affordable if it means one-on-one or if you have a task. Even if you just have a question, feel free to ask. Sometimes we discuss for free. It's not always to pay. Feel free. It's mathematics world. We need to learn the mathematics, understand the mathematics, love it, and use it in future. Use it in our careers. It's very important. Okay? So these methods that we've done, please, if you see any question demanding synthetic, you know it's a bonus question. Long division is a bonus question. Get all the marks. Okay. Thank you for watching. Stay blessed.